Hi everyone. We're getting further into this conic section here, and this is section 10.5, and it has the hyperbola. And so I feel like we can do a quick lecture to help you with the equation for this one, but I feel like they're all so similar that you're probably getting pretty good. Remember, this is a center of 0, 0. So our main two formulas, you can see, here's our horizontal, here's our vertical. So horizontal means the hyperbola has the two pieces going from here to here out off the x, and then the vertical, the pieces are off of the y. And the formulas are similar, but they have the minus sign in between, which made them different from the ellipse or the circle. And so one of them, when they're horizontal, it's going to have the larger number under the x and then minus the smaller number under the y. Whereas on the vertical, you're going to have the y squared first with the larger number under it minus the x squared. So if we start with x squared minus, then we're going to have horizontal. If we start with y squared minus, then we'll have vertical. When we look at these shapes, we look at the transverse axis is horizontal or vertical. So they talk a little bit about this transverse axis. So it lines up with our horizontal or vertical. Our vertices are where you go out and start your shape here. So those are found at A. That's our larger number under X or Y, depending on which side. If they're under the X, guess where they are on the point? They're on the X. If they're under the Y, they are on the Y. Now remember, it's A squared here, A here, so you take the square root of that number. The foci is the same as before, except now it's a plus to be able to find that versus the minus that we had in the ellipse. And then the new thing is this asymptote. These do have asymptotes that go this way and this way. So if you go straight down the middle here, that's the line y equals x. And this one would be y equals negative x. So it's really similar to that line, but it is the b over a or a over b. That is going to be so find b and a, and that's going to be your two asymptote lines. They do plus or minus, but it's two lines, right? The two green ones on both sides. All right, so that's kind of what we're learning in this one. And now and a lot of the things they're doing, they're deriving the formulas. How do we come up with these formulas? And they're showing you different things like that, which really does help with your understanding. So if you want to read through those, that's great. I'm going to give a couple examples of the formula here and using these, and then I'm going to leave the rest up to you. Okay, so my first example will be x squared over 121 minus y squared over 144 equals 1. And remember, again, it has to equal 1. So if it doesn't equal 1, then you need to divide by that number to make it equal 1. So we're here. And then the next step, let's define our A and our B just so we can use them in all those formulas we're given. A is going to be under our x squared, and that's the square of it. So take the square root and we'd get 11. And the square root of 144 would give us 12. So there's our A, there's our B. That helps with our vertice. And we'll graph this in the end. Our vertices, we use our A. So if it is under the x, then the vertice is in the x position, and it's plus or minus. And that means you're going to go out on that x and go out 11, and those are going to be your two starting spots for your half circle shapes there. And then the next thing we'd want is our foci. And our foci is found, right, as our c squared is equal to a squared, which is 121, plus 144. And so we'd add those together and get 265. And the square root that, and you get plus or minus, don't forget the plus or minus, 265. And so we would put that as our point, and our point on the vertical, or excuse me, horizontal, is going to be plus or minus the square root of 265, 0. It's in the x position, x position, x position. Okay, so that's our foci. And our last thing is our asymptote. Asymptote. Let's see. Asymptote is found at y equals x, almost, with that proportion of the b, and it could be plus or minus, that b over a. Well, b is 12, so this would be 12/11 x. You could write this, probably makes more sense to write the two lines separate. Oops, 11x, and y equals negative 12/11x. So when we write that plus or minus, that's the same thing as two separate equations. Same here, same here. So a lot of times when you write your answers in, they're not just written by hand. When you write them in Math Excel, you're going to have to separate them. So make sure I show you that. Now let's graph this. Now we know it is going to be a horizontal, and they're going to be out at 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. I made them small so I could see or fit them, and this would be our shape. Both sides here. There we go. There's our shape. And the center is still 0, 0. We haven't moved around that center of the hyperbola. And that focus would be out here at the square root of 265. I don't know what that is. So 2 square root of 265 is about 16. So this was at 11. 12, 13, 14, 15, 16.27. So that's about where that F1, F2, the focus are. Oops, we usually call that one the positive F1. All right, and then the asymptotes would be the lines. They go right up here, and they better have the slopes of negative 12/11 and 12/11. Okay, those didn't show up super well, but there you go. And they should go through the center. That's what you're looking for. This one goes this way. Let's do one more that goes the other direction. What if we have y squared over 81 minus x squared over 16 equals 1. So again, it's starting with, oops, you can't see what I'm doing. It's starting with y squared. So y squared over 81 minus x squared over 16. So it's starting with y. That's going to mean it's going to be the vertical hyperbola. And let's list everything here that we should know. Let's start with those vertices. And that's just going to be how far out you go, right? Or we're going this way this time. And that's going to be our A. So, what's our A? What's our B on this one? A is the square root of 81, which is 9, and then the square root of 4 for B, which is 16. So it's going to have A squared, B squared. And so our vertices will be found at 0, because they're going to be on the Y, plus or minus the 9. All right, and then I wrote it something down wrong on my notes. So if the foci is going to be found at c squared equals 81 plus 16. So c squared is equal to 97. And so the square root plus or minus of 97, can't reduce that square root down, so that's your answer. Basically, nothing divides into 97 that you can take the square root of to simplify that. If that would have been a 32, you could have simplified it further because the square root of 16 is possible, and that divides into 32. So this is our foci almost. Remember, this one's all y, so we're going to go 0 plus or minus the square root of 97. Those are the 2 points at plus or minus. And the asymptote is going to be at y equals, this time it is A over B, so it's going to be 9/4 x. And that, or it could be y equals negative 9/4 x. So you could do the plus or minus, or you could put in, oops, it doesn't really look like a 4. There we go. So just a general idea, I'm just going to sketch this one. You would go up to 9, down to negative 9, and the shape would be here and here. And then you could see the foci would be here and here, so it better be bigger than 9. We want to take the square root of 9, just close to 10, so it should be a little bit further there. And then you can see, you could double check your formulas here for your two asymptotes. So you could graph all three, your asymptotes and your original, on that Desmos calculator and make sure they look right. It's a good way to check your answer. So hopefully, I feel like you're probably getting quicker at these sections as we work through them. Hopefully that helps you with the hyperbola.